Hello and welcome to factoring trinomials with a equals 1. This is the notes for that. Factoring trinomials when a equals 1. Well, this first page we're going to talk about goes a little bit into kind of what factors are. So we'll spend a little bit of time here. Now this table up here, all those different kind of sentences there or different phrases, they're all essentially the same thing. They're all saying that r is a root of p of x, or r, if you plug it into p of x, will equal 0. So real number r is a root of the polynomial equation p of x equals 0. P of r equals 0. You plug in r for p of x, you get 0. R is just any whole number, okay? R is an intercept of the graph of p of x. Okay, so if all that's true, r is an intercept, meaning at that number, whatever number r is, okay, the graph will cross the x-axis. That's it. R being x-intercept. Okay, if r is a root, then x minus r is a factor of p of x, and that's kind of where we're going with the x minus r stuff, or x minus anything, plus or minus anything. When you divide, the rule just means when you divide p of x by x minus r, the remainder will be 0. So if you use synthetic division, okay, with x minus r, you already know synthetic division, you'll get 0 as remainder because r would be a factor of p of x. It would come out evenly. And the last one just says r is a 0 of px. Okay, these are all just kind of different situations between a factor and its function, all right, or its equation. Factors are super interesting. There's a lot that we can learn and do about graphs when we can find factors. So this whole unit is going to be about factoring, unit 4. And really it's kind of the gateway to large portions of the rest of Algebra 2. Okay, if you can factor really well, you can do a lot of the rest of the units in Algebra 2 really well, or some of them, I should say, about half of them. So really focus here. All right, the directions for these examples at the bottom say, are the following factors of the given polynomial? So look at example 5. It says, is x plus 1 a factor of x squared minus 3x plus 1? Well, there's a bunch of ways to find out, okay? We can graph x squared minus 3x plus 1 and see where it crosses the x-axis, okay? We can substitution, which is a fancy way of just saying plug it in, okay? And that's what I'm going to do with these bottom ones because it's the easiest. We'll do some more of the other stuff later. You can do it by synthetic division. Okay, so I could take x plus 1, take the negative 1, and just synthetically divide into x squared minus 3x plus 1, just like we did before. Okay, if it comes out 0, then it's a factor. Or we could use the quadratic formula. Notice it says, if possible. I hate using the quadratic formula unless I have to. Okay, I don't want to do it. It takes forever. It takes a lot of writing. And also, you can only use it when you have a trinomial with degree 2, where the leading term is squared, right? Squared, then x, then no x. You can't do it with trinomials or anything that's not a trinomial with a square term. For example, you can't do it with this. Okay, that's a polynomial with 4 terms, and it's got a 4th degree, so in a third degree, wouldn't be able to do it, even if it was a trinomial. Okay, so quadratic formula is just annoying. Unfortunately, with complex numbers, it's kind of the only way to get them, and we have to use it sometimes. But I try to do these other 3 whenever possible instead. So for these, are these factors? Okay, well, you just have to plug in. If you plug in, well, let's talk about it. X plus 1. Okay, if you plug in negative 1, why negative 1? Just taking the opposite of this. If you plug in negative 1 into this, do we get 0? Okay, well, let's see. Okay, so negative 1, parentheses squared, minus 3 times negative 1, plus 1. Well, that's just negative 1 times negative 1 is 1. Negative 3 times a negative 1 is a positive 3, plus 1. 1 plus 3 plus 1 is not 0. That's 5. So no, x plus 1 is not a factor. Let's try the next one. I'm just taking the opposite of x plus 2. Well, that'd be a negative 2. Okay, let's plug that in where I see x. All right, 3 times negative 2 to the fourth. Well, the negative 2 is the only thing raised there. Plus 6, then raising negative 2 to the third. Minus 5 times the negative 2, minus 10. Well, don't want to confuse that. Negative 2 to the fourth, I think that's 16. So 3 times 16 plus negative 2 to the third is negative 8. Negative 2 times negative 2 times negative 2. Trust me, you can plug in your calculator. Well, negative 5 times negative 2 is a positive 10. Minus 10. Oops, 10. Well, look at that. Those will cancel. Now I just have to do some math. 3 times 16, I think that's 48. 6 times a negative 8, well, that's a negative 48. 48 plus negative 48, that's 0. So is x plus 2 a factor of that? Yes. We plugged in negative 2, and we got out 0. Oh, well, I wrote no. What I meant was yes. We plugged in negative 2, and we got out 0. Okay, that's one way. That's one way to figure out factors. Just substitute it in. Moving on. All right. Now on to quadratic trinomials. Okay. And this is always where the squared term has a 1 in front of it, or you don't see anything. Okay. So you don't see like 3y squared there, for example. You see just y squared. The next one is just a squared. Okay. The squared term only has a 1. In fact, these are in the form of ax squared plus bx plus c. Okay, where a, b, and c are just numbers. Okay, so it's x squared, x, no x. And for this lesson, we're only going to do problems where a is 1. Okay, so notice none of these on your screen right now have a number in front of the squared term. Okay, they're all 1. So when you see that, there's actually a quick little, not necessarily quick, but a quick little guess and check for factoring. Okay, so when I see ax squared plus bx plus c, in this case y squared plus 5y plus 6, and there's no number in front of the y squared, I immediately do this. Because I know that is going to factor into 2 binomials. All right, hopefully. Not always, but usually. Okay. And what I'm looking for, okay, I'm looking specifically at those 2 numbers. Okay. I need 2 numbers that multiply. Okay, multiply. Is that a good symbol for multiply? To be 6. And those 2 numbers need to also add to be 5. Okay, so they multiply to be the last term, and they add to be the first term. So what 2 numbers multiply to be 6 and add to be 5? Well, I think that's 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. Okay, so I'm going to write those in. 2 and 3. And then I'm going to split whatever my variable is. In this case, it's a y. There. A positive 2 and a positive 3. All right. And those 2, I believe, are the factors, okay, of that trinomial. And there's a quick way to check. How can you check? You just FOIL that. Yeah, you just have to multiply those 2 binomials out, FOIL them, and see if you get the original answer. So let's do that. Y times y is y squared first. Outer is y times 3 plus 3y. 2 inner is 2 times y is 2y, plus 2y. 2 times 6 is the last thing I have to do, the L of the FOIL. 2 times 3, excuse me. 2 times 3 is 6. Right, then just add like terms. 3y plus 2y is 5y. Bring down my other 2 things. Y squared plus 5y plus 6, is that what we started with? It sure is. Nice job. Those two binomials, y plus 2 and y plus 3, are factors of the original. You could also check by plugging in -2 and -3 and seeing if they're both come out to be 0. I think that takes longer than just foiling. Okay, always foil to check just to make sure. All right, let's do the next one. 2, I'm going to switch colors. 2, or a squared minus 15a minus 16. All right, I'll put my two binomials up. What two numbers multiply to be 16 but add to be -15? Two numbers that multiply to be -16 but add to be -15. Well, 16 and 1 seems like a good bet. Okay. 8 and 2, 8 plus 2 is 10. That's not going to get me to 15. 4 and 4 multiply to be 16, but 4 plus 4 is 8. That's not going to be 15. So 16 and 1. Well, I can manipulate 16 and 1 to get 15. So first of all, these have to multiply to be -16. So one of these has to be negative. Well, I'm guessing that this has to be negative because that's a -15. That's a really big negative number, right? And in fact, let's just plug it in and see. Plus 1, okay, positive 1. So a minus 16, a plus 1, is -16 plus 1, -15? It is, okay? And they multiply by -16, so this should work out. Let's FOIL. A times a is a squared. -16 times 1 is a times 1 is positive. Gotta do outside. A times positive 1 is positive 1a. -16 times a is -16a. -16 times 1 is -16. Okay, so my first and last terms look good. Let's add these two. 1 plus -16a is -15a. Yep, nice. We got the right answer. All right, I'll do one more real quick. Oh man, my ax squared is going to follow us down the page up there in blue. Okay, well, that's going to be with us forever now. All right, let's go to green for this one. 49 is a tough one. What two things multiply by 49? It's 49 and 1 or 7 and 7. Okay. Is 49 and 1 going to somehow add to be 14? I don't think so. Okay. So 7 and 7, well, that's 14. So let's mess around with 7 and 7. Okay. Well, it needs to be -14. So one of these is going to have to be negative. In fact, they both have to be negative. -7 plus -7 is -14. Does that multiply to be 49? Yep, -7 times -7. Negatives cancel. Positive 49. Nice. Okay. So they multiply to be the last, no, the C, and they add to be the B. All right, let's throw some x's in there since that's the variable we're working with. And let's FOIL just to make sure. X times x is x squared. X times -7. Ooh, that's bad. Let me just erase that real quick. All right, start over. FOIL this out to check. X times x is x squared. X times -7 is -7x. To the inside, -7 times x is -7x. -7 times -7 is positive 49. Then I just add the two x terms in the middle, and I get -14x. Awesome. Okay, that is what we needed. X squared minus 14x plus 49. All right, go ahead and try the next one on your own. This is the last example. Give this a try and hit pause. And otherwise, I'm just going to keep going on and do this one. So hit pause now. Otherwise, here comes the answers. Do this one in somewhat of a purple. All right. Trinomial. A is 1. So I'm going to set up my two binomials here. Two sets of parentheses. I know that That should be a 1 in there, so it's like a negative 1. What multiplies to be negative 12, but adds to be negative 1? Well, what things multiply to be negative 12? 12 and 1, 6 and 2, and 4 and 3. And I think that's it. This is negative. Okay, so which of these can I manipulate to be a negative 1? Which can I manipulate to get a negative 1? Well, 12 minus 1 is 11. 12 plus 1 is 13, so that's not going to work. 6 plus 2 is 8. 6 minus 2 is 4. So I'm not going to get negative 1 with 6 and 2 at all. So those two are out. 4 and 3. Well, 4 minus 3 is 1, okay? So we can mess around with a negative there. So I'm going to put my 4 and 3 in. So which number should I put the negative on? In fact, you can always do this. If you need it to end up being negative, you can always just put the negative on the bigger number. All right. So then ask yourself, is negative 4 plus 3 negative 1? Certainly is. So I got to squeeze an m in here, squeeze an m in there. Let's FOIL. M squared minus 4m plus 3m. Did that backwards. Minus 12. Okay, add those up. Negative m. Is that what we needed? M squared minus m minus 12. Sure is. Those two are factors of the original. Nice. Another way to check is just to plug in 4 and negative 3, the opposites of those, and see if you get 0. Okay, I'm sure you will. That's it for factoring trinomials with a equals 1.